given input, some input and input to output known combination, some are used for the purpose of training and some rest of them are used for the purpose of testing at the cognition phase. So now one thing must be noted in this context. When I am talking about an error, so the error is realized at the output input. Okay. So given some input with arbitrary weight adjustment, the output that is expected minus the output that is observed gives you the dimension or gives you the quantum of error. Okay. Now, please note, we can say that the error is induced because the knowledge about, at least some knowledge about what output should be given that input is known to us. It is because of the fact that we know the cognition phase for some inputs what should be the output. Since that knowledge is there beforehand, that is why we can say whether there is any error and if there are, how much it is. Think that way. When a mother is in the process of making her child aware about the shape of a ball or a color of a ball, it's for sure that the mother herself knows it. Mother herself is in the knowledge of it, right? So that means in a training learning model, it is assumed that the training, component, the trainer is trained, or the trainer knows, given an input, at least during training or testing phase, given input what should be the output. Okay? Think of a situation that we are encountering something which is not known before. That means an object or something is encountered for the first time which is not known to anybody. Okay? For example, tsunami for the first time, few years back. Was it known to anybody? No. So the question is, who is the trainer? And who is the learner? So out of these two entities, trainer and learner, there is a distinct difference that in terms of knowledge, trainer has got some additional knowledge which learner does not have. And because of this, the question of the trainer training imparting training to the learner makes meaningful and sensible. Otherwise, the question of knowledge percolation from trainer set to the learner set doesn't make any sense. What do you do? This is what is known as supervised learning. So supervised learning means there is a supervisor who is able to consult or who is able to determine as to given a specific input, the output generated, whether it is proper or not. Clear? I repeat. The supervisor is an entity in a training learning model where supervisor knows that given an input, what should be the output. It is known to the supervisor. And only by virtue of the fact that the supervisor knows it, he or she can train the learner. So that is why the learning that is taking place is supervised mode of learning, where the role of the supervisor is unquestionable and sacrosanct for that matter. When a teacher teaches something in a class, the role of the teacher is that of the supervisor. If the teacher teaches something wrong, nothing will. Very difficult proposition, right? So it's a matter of assumption that the supervisor, quote unquote, is all powerful in the sense in terms of knowledge, unquestioned, unquestionable, and sacrosanct. And given that fact, it is only on the basis of the supervisor, the question of how much error is induced is determined. Because what is observed and what is obtained, what is observed and what is expected, and that difference can only be determined by the supervisor. So that is why it is a supervised mode of learning. And because of the role of this error induced, it can be propagated back or fed back, whatever it may be, and weights may be adjusted subsequently. And the training learning loop goes on continuing until stability. Stability means
Error.
Error becomes negligible. Who is going to declare that? It is within the acceptable limit. Once again, the supervisor. Okay? So this thing is the supervised mode of learning. Well then, the example of tsunami. Everybody is at the same level. No supervisor, nothing. Question is, who trained us? Who is the supervisor in unsupervised learning? First of all, in unsupervised learning, there is no knowledge whatsoever regarding some given input to output mapping information. That is available in case of supervised learning. In case of supervised learning, some input to output information is known, which can be used for the purpose of training as well as testing. Unfortunately, in unsupervised mode of learning, no such combination is there. Think of a situation prior to tsunami and after tsunami. What was the level of information or knowledge prior to tsunami? Nothing. And because of the absence of any knowledge whatsoever, everybody was at the same level. No additional knowledge to anybody. So it's unsupervised mode of learning. Nobody was in a position to take the role of a supervisor out there, except nature. Okay? Unfortunately, nature is a what should I say, universal trainer, but very bad trainer in the sense it doesn't allow any feedback sort of mechanism. Something was to happen, it has happened. Tsunami was to happen, happened. Irrespective of whatever disastrous effect it had, it's a matter of history. Now the question is, today, do we know what tsunami is? Answer is yes. Are we prepared to have the disaster mitigation that is needed in case of a tsunami type of scenario? Answer is yes. Can we predict that tsunami-like type of thing is going to take place in near future and remedial measure out of it? Yes. So, learning took place, but not in supervised mode, but in unsupervised mode. This is what is, in this context, the question of error is not there. Right? So this is why it is unsupervised mode of learning. Okay? There is another variant. Self-supervised. Any clue from the audience, please? Where it could be self-supervised?
Train itself.
Exactly. The trainer in supervised learning, out of this trainer and learner, supervised learning, out of this trainer and learner, in self-supervised learning. In self-supervised learning, P equal to L. It's like practicing after, say, Madhyamik test, practicing mathematical or mathematics problem solving using test paper done by the candidate, intending candidate himself or herself. He or she, opens a particularly new, mathematics paper, say for example, the test paper, and tries to solve it. Mock test. Self-supervised learning. Whenever he or she is stuck up for some reason, whatever, he just puts additional effort to get it solved by himself or herself in most of the occasions. In case it fails, okay? So self-supervised form of learning is applicable until and unless it encounters deadlock. The moment there is anything, further movement is not possible, and the task of training remains unfinished, then the consultation with the supervision becomes imperative and necessary.
So তাহলে ওই সেমি সুপারভাইজড লার্নিং একটা আছে না, ওটা কি? সেমি সুপারভাইজড
সেমি সুপারভাইজড তো বললাম, সেমি সুপারভাইজ যতক্ষণ যে নিজে পারছে ঠিক আছে,
তাহলে সেলফ সুপারভাইজ মানে সেমি সুপারভাইজ,
সেমি বলছো,
সেমি সুপারভাইজ আছে না একটা?
Semi-supervised, collaborative supervised, vision, supervised learning, so many things are there. Think of your, I'm not sure, your hostel days, okay? Whether you are used to it, you were used to it, I don't know. Personally, I was used to it. So I know in hostel days what used to happen before the examination. It was a collective type of thing. So group of 5 or 4 students, 5 to 6 students, we used to sit together. Something comes clear to someone, it's just broadcast mode. Everybody gets learned about it. Okay? No formal boundary of teaching learning mechanism. It's neither comes under the purview of supervised, nor unsupervised, nor self-supervised. It's a collective manner and effective. The question is, learning is necessary. In different contexts, different forms of learning are necessary. And a particular type of learning may not be useful in some other context. Suppose I have 10 days for study leave. Now, is it suggested that we should have a supervised learning form of learning? Appoint a new teacher for 10 days. Is it productive? In all likelihood, it is unproductive. Okay. So, depending upon a specific context, which form of learning is useful? First of all, different types of learning is very useful in different contexts, and which one is the most effective? That is what you must mention. Okay? Okay. This is some points regarding learning. There are so many other issues, but I will sum up a few words regarding. Before that, any question? Whatever we have discussed so far. Otherwise, we shall move into our next topic on hybrid computation. There is some preliminary discussions and then stop.
স্যার ওই সম আছে না, সেলফ অর্গানাইজিং ম্যাপ, ওটা কি ওই সেলফ সুপারভাইজিং এর মধ্যে পড়ছে?
This is called adaptive basically. Some adaptation takes place in self-supervised mode, right? Basically, the mapping, first of all, there is mapping. You must appreciate. The mapping characteristic is, or the information regarding the mapping characteristic is determined in self-supervised mode. That is why it is called self-organizing map of song. Stupid problem. Self-organizing. Okay. In fact, his article, through his article on song of self-organizing map, he showed that the nature of fixing your mapping or map that can be done in self-supervised. That was the fundamental finding. Now, let us come to hybrid computation. Now, yesterday I came to know that you had some exposure to evolutionary computation, genetic algorithm, multi-objective computation, things like that. By tomorrow, you will have enough of exposure on fuzzy mathematics, fuzzy logic. Today, some knowledge has been imparted on neural network. Now, whatever it may be, point is that different components of soft computing have got different roles to play and different instances. For example, when we are using genetic algorithm or evolutionary computation, the basic purpose of evolutionary computation or genetic algorithm is to deal with the purpose of optimization. So, when we are in need of optimization, and especially when classical optimization techniques fail, mostly, genetic algorithms or evolutionary computation based techniques come to your rescue. And colony optimization, not to speak of genetic algorithm alone, simulated rendering, and colony optimization, swarm optimization, swarm intelligence. So all these different type of techniques, they come under the purview of evolutionary computation. And all of them have the similarity in respect of their purpose. The purpose is optimization. And through the optimization, reaching to the optimum solution in a big search or complex search space. Okay. So optimization is the preliminary task of evolutionary computation or any technique here. Come to fuzzy, which we will discuss tomorrow. Just for a glimpse, fuzzy deals with uncertainty handling, handling vagueness. So when we are not in a precise situation, today is a sunny day. Explain, define formally what is sun. Anything? He is a tall boy. How do you define tall? Okay. So this type of expressions, which are not precise, but their meanings are understandable, can be perceived. When we have to, in real life situations, we have to deal with situations like this, fuzzy or post generation or higher fuzzy mathematics, all these things are there to come to your rescue. That means fuzzy is primarily responsible for handling uncertainties, imprecision, vagueness. Okay? Today we have seen how neural network can be used for the purpose of learning, training, and through the process of training, how how a system itself becomes or itself starts behaving in an intelligent manner, to some extent at least. Because after all, once it is trained, an artificial neural network is trained, it is capable or expected to identify or to classify an object properly, provided the training is proper. Okay. That means, after the cognition phase is successfully done, next the question of recognition, the proper recognition is quite expected of an artificial neural network. Okay? So, the question of classification, the question of recognition, these things come under the purview of artificial neural network. Okay? So these components of soft computing, each and every component has got its own aim and scope. Though unfortunately real life is not that simple, where the different problems of life are classified properly in that sense. In fact, in most real life situations, we need the combined effect of more than one techniques. That is where the problem is. So, for example, we may need or may be in need of learning, training and learning, but in an optimized way. Now, what is the solution? Optimization comes under the purview of evolutionary computation. Okay? And training learning comes under the purview of artificial neural network. So what do we do? Dealing with or training and learning imprecise issues in that way. I am trying to train or learn through artificial neural network something which is characteristically imprecise or vague or uncertain. What to do? So it means that in real life, in these type of situations, taking the advantage of only one technique is not sufficient. Okay? Or in other words, in this type of situations, you may be in need of the combined effect of more than one technique. In the previous situation, since the optimization along with the question of, in the previous example, optimization along with the question of cognition and recognition was there. So it is definitely expected that a combined effect, if it is at all possible, a combined effect of some evolutionary computational technique clubbed together with artificial neural network might be more useful, more beneficial. This is because each and every technique has got its own limitations as well as strong points. Now, the weak point of one technique can be supplemented by the strength of the other. If it can be a collaborative. So it's like that. So the weakness of one is being supplemented by the strength of another. This gives rise to what is known as hybrid computation.
স্যার এখানে তো ধরুন আমি সোয়াম
In this context, when I am coupling evolutionary computation or genetic algorithm, which primarily takes care of the optimization part, along with the artificial neural network, which is responsible for taking care of the cognition or recognition part, when they are clubbed together, it becomes a hybrid technique, maybe a neurogenetic technique. Okay, neural network and neuro, and genetic comes from the genetic algorithm. So it's a neurogenetic approach. In the latter part, when my artificial neural network has to accommodate imprecise or sort of fake type of scenarios, it has to handle. So for vagueness, fuzzy part, for recognition cognition or cognition, or training on learning, whatever it may be, my artificial neural network part. So put together, it's a neurophagy approach. Another instance of hybrid intelligence. Let us give a simple example. Now, think of a perceptron. Think of a perceptron. So, what we are trying to achieve as a minimum error that we want to achieve. So, it's a question of optimization, error minimization. Okay? And through the epoch, okay, we try to achieve that. Think. Instead of propagating back the error information and all that time and again, epoch one after another, if it is possible to minimize the error, that means adjust the weights and try to fix the weights so that for which weight combination the error is minimal. So then the entire problem is decomposed into two parts. One is the unknown weight part, which needs minimization. Okay? So in that case, for that part, the problem is which weight combination is going to give the minimum error at the output level. Okay? So now let us think. That component I leave to some genetic algorithm or some evolutionary approach. And once this genetic algorithm gives you the result in the form of properly adjusted weights, I just put those weights in my neural network. I forget about taking back propagation, error and all these things. You understand what I am saying? It's a hybrid approach. It's a neurogenetic approach once again, or neuroevolutionary approach. Another instance of hybrid approach. Several approaches we can evolve. The basic principle is to overcome the drawback of another method by the strength of love. Okay? That is why this collaboration is all about. And this is the essence of hybrid soft computing or hybrid computation. Okay? And there are, in fact, recently hybrid computation, hybrid intelligence, these things are coming in a big way. In fact, there are dedicated transactions and there are dedicated channels for it, with so many reportings in different type of applications. In fact, frankly speaking, classical form of computing techniques, they are with their drawbacks well known. The question of hybrid supplementation is very much there. So people have started thinking in that terms. Okay? Okay, let me stop here. Any other question?
Sir, hybrid model is open, sir. Open any
প্রচুর কাজ পড়ার আছে প্রচুর কাজ করতে পারে
যে কোনো দুটো জিনিসকে মার্জ করা
স্যার হাইব্রিড দিয়ে কি ভালো জানা হয়?
নিউরো সিমুলেটেড ট্রেনিং আছে আমাদের কিছু কাজ আছে দেখতে পাবো
স্যার হাইব্রিড দিয়ে জানা হবে ভালো জানা
Again, difficult question.
ওই জার্নালটা সব হচ্ছে হ্যাঁ কেন বললাম তো হাইব্রিডের উপরে প্রচুর ইনফ্যাক্ট হাইব্রিড ইন্টেলিজেন্স সিস্টেম বলে একটা জার্নাল আছে এছাড়া IEEE ট্রানজাকশনের এফেক্টিভ কম্পিউটিং বলে একটা জিনিস আছে যেখানে হাইব্রিড অ্যাপ্রোচ ইজ ভেরি মাচ ইউজফুল এফেক্টিভ কম্পিউটিং
Sir, shed some light on SOM,
হ্যাঁ
self-organization map.
সেল অর্গানাইজেশন হ্যাঁ what
Can you tell me something about that?
self-organizing map I was in fact it is there it's advanced particularly
হাইব্রিড ইন্টেলিজেন্স আছে
look the term map is indicative of some transformation from some input to output. So y equal to fx is basically that some relation. So self-organizing map is basically trying to fix an unknown map in some context. The map is not known. Unknown map through the process of self-organization or self-supervision.
Self-supervising.
Self-supervised. So this is, you can think that way. This is a self-supervised mode of adjustment of your map, or finalization